Hello everyone. Today we are discuss about interprocess communication mechanism. Interprocess communication mechanism exchange of data between two or more separate independent process threads is possible using interprocess communication mechanism. Operating systems provide facilities or resources for interprocess communication such as message queues, semaphores and shared memory. A complex programming environment often uses multiple cooperating processes to perform related operations. These processes must communicate with each other and share resources and information. The kernel must provide mechanisms that makes this possible. These mechanisms are correlatively referred to as interprocess communication. Distributed computing systems make use of these facilities or resources to provide application programming interface which allows IPC to be programmed at a higher level of abstractions. Five types of interprocess communication are as follows. Shared memory permits process to communicate by simple reading and writing to a specified memory location. Mapped memory is similar to shared memory except that it is associated with a file in the file system. Pipes permit sequential communication from one process to a related process. First in first out are similar to pipes except that unrelated process can communicate because the pipe is given a name in the file system. Sockets support communication between unrelated process even on different computers. Here is a name, a description, scope and use. Here is a file and pipe named pipe, signal, shared memory and socket. The description: data is written to and read from a typical Unix file. Any number of processes can interoperate. It's a local, use sharing large data sets. Then next one, pipe. Data is transferred between two processes using dedicated file descriptor. Communication occurs only between a parent and a child process. It's a local. Simple data sharing such as producer and consumer. A named pipe. Data is exchanged between processes via dedicated file descriptor. Communication can occur between any two pair processes on the same host. So, scope for local. Producer and consumer are common command and control as demonstrate with MySQL server and its command line query utility. Then the signal. An interrupt allowed the application to a specific condition. Is scope for local. Cannot transfer data in a signal, so mostly useful for process management. Shared memory. Information is shared by reading and writing from a common segment of memory. So for local. Cooperative work of any kind, especially if security is required. Then socket. After special setup, data is transferred using common input or output operations. Scope for local or remote. Network services such as FTP, SSH and the Apache web server. Purpose of IPC. First one, data transfer. One process may wish to send data to another process. Sharing data. Multiple processes may wish to operate on shared data such that if a process modifies, the data that change will be immediately visible to other process sharing it. Event modification. A process may wish to notify another process or set of process that some event has occurred. Resource sharing. The kernel provides default schematics for resource allocation. They are not suitable for all applications. Process control. A process such as a debugger may wish to assume complete control over the execution of another process. Interprocess communication has two forms: IPC on same host and IPC on different host. Is a kernel IPC on same host and IPC on different host. Here first one is IPC on same host, user process and the kernel to user process. Here different host means kernel to kernel and different users. IPC used for two functions, synchronization and another message passing. Synchronization used to coordinate access to resources among processes and also to coordinate the execution of these processes. They are record locking, semaphores, mutexes, and conditions variables. Message passing used when process wish to exchange information. Message passing takes several forms such as pipes, first in first out, messages queues, and shared memory. Features of message passing: simplicity. Message passing system should be simple and easy to use. It should be possible to communicate with old and new applications. Uniform semantics. Message passing is used for two types of IPC. First one, local communication. It is communicating process are on the same node. Second one, remote communication. Communicating process are on the different nodes. Third one, efficiency. IPC becomes so expensive if message passing system is not effective. User try avoiding two IPC for their applications. Message passing system will become more efficient if we try to avoid more message exchanges during communication process. For example, avoiding the cost of establishing and terminating connection, minimizing the cost of maintaining the connections, piggybacking of acknowledgement. Fourth one, reliability. Distributed systems are prone to different catastrophic events such as node crashes or physical link failures. Loss of messages because of communication link fails. To handle the lost messages, we require acknowledgement and retransmission policy. Duplicate message is one of the major problems. This happens because of timeouts or events of failures. Fifth one, correctness. Correctness is a feature related to IPC protocol. For group communication is used related to correctness or as follows. Autonomicity. Every message sent to group of receiver will be delivered to either all of them or none of them. Order delivery. Messages arrive to all receivers in an order acceptable to the application. Surveyability. Messages will be correctly delivered despite partial failures of process, machine or communication links. Then fourth one, security. Message passing system must provide a secure end-to-end communication. Fifth one, portability. Message passing system should itself be portable. IPC message format. Message passing system requires the synchronization and communication between the two processes. Message passing used as a method of communication in microkernel. Message passing systems come in many forms. Messages sent by a process can be either fixed or variable size. The actual function of message passing is normally provided in the form of a pair of primitives. First one, send, destination name and message, receiver, source name and message, message. Send primitive is used for sending a message to destination. Process send information in the form of a message to another process designed by a destination. A process receives information by executing the receive primitive, which indicates the source of the sending process and the message. Design characteristics of message system for IPC. First one, synchronization between the process, addressing, format of the message, and fourth one, queuing discipline. Use in IPC5 message passing. Message is a block of information. A message is a meaningful formatted block of information sent by the sender process to the receiver process. The message block consists of a fixed length header followed by a variable size collection of typed data objects. The header block of a message may have the following elements. First one, address, a set of characters that uniquely identify both the sender and receiver. Second one, sequence number, It is the message identifier to identify duplicate and lost messages in case of system failures. Third one, structural information. It has two parts. The type part that specifies whether the data to be sent the receiver is included within the message or the message only contains a pointer to the data. The second part specifies length of the variable size message. It is a message structure block diagram. Here is the variable size collection of type data, and next fixed length headers. The first one is the structural information, another addresses, sender is the sequence number of message ID, number of bytes elements and type, then address receiver side, receiving process address and sending process address. Some important issues to be considered for the design of an IPC protocol based message passing system. First one, the sender identity. Second one, the receiver identity. Third one, number of receivers. Fourth one, guaranteed acceptance of send message by the receiver. Fifth one, acknowledgement by the sender. Sixth one, handling system crashes or link failures. Seventh one, handling of buffers. Eighth one, orders of delivery of messages. IPC synchronization. A send operation can be synchronized as or asynchronous. A receive operation can be blocking or non-blocking. Sender and receiver process can be blocking mode or non-blocking mode. Different possibility of sender and receivers are as follow. First one, blocking send, blocking receive. Second one, non-blocking send, block receive. Third one, non-blocking send, non-blocking receive. Blocking send, blocking receive. Blocking send must wait for the receiver to receive the message. Synchronous communication is an example of blocking send. Both process, sender and receiver are blocked until the message is delivered. Renders. Sending a message to another process leaving, the sender process suspended until the message is received and processed. Non-blocking send, blocking receive. Sender is free to send the message, but receiver is blocked until the requested message arrives. Asynchronous communication is an example of non-blocking send. Asynchronous communication with non-blocking send increases throughput by reducing the time that process spent waiting. Natural concurrent programming task uses the non-blocking send. Non-blocking send is the overhead on the programmer for determine that a message has been received or not. Shared memory. A region of memory that is shared by cooperation process is established. Process can then exchange information by reading any and writing data to the shared region. Shared memory allows maximum speed and convenience of communication, as it can be done at memory speeds when within a computer. Shared memory is faster than message passing, as message passing systems are typically implemented using system call and thus require the more time consuming task of kernel intervention. Contrast, in shared memory systems call are required only to establish shared memory regions. Thank you.